All right, so quick video here. You've got a triangle. It's a right triangle that I didn't label. And this little segment of it over here is 18 feet. And you know that this is 33 degrees. The question is going to be to, solve for all the missing sides. That's what we're going to be doing. Now, this segment, BD, is actually an altitude of the right triangle. Now, an altitude, it's basically a segment that you drop from one of the vertex or one of the vertices, and it meets perpendicular with the opposite side. So that's what's going on here. So, got a picture of it for you. So this segment, BD, is going to be perpendicular to this hypotenuse over here. Now, something that I didn't know that is true about right triangles, when you drop the altitude like this, you actually create other similar triangles. And here's why. So similar triangles are triangles that have the same angles. So we know that this is 90 right here, and we know that this is 90 right here. So that's already one angle. This angle is 33, which means we have 33, 90, and whatever this is, that have to add up to 180. See here, that's going to be 57 degrees right here. 57 degrees. Now, if this is 57 and that's 90, what I'm doing is I'm looking at this smallest triangle here. If you have 57 and 90 there, then this little angle, this little part, has to be 33 degrees. And because of this whole thing being 90 and this is 33 degrees, that means that this little angle right here, the last angle in the medium-sized triangle, that one's going to be 57. So that's why you have three similar triangles here, right? Because all the angles are the same in each of them. Now, let's get to solving this thing. Let's see here. I know that this is adjacent. This side right here is adjacent to my 33-degree angle. So I know I'm going to have to use cosine. So adjacent over hypotenuse. So cosine of 33 is equal to adjacent over hypotenuse, and the adjacent is 18. All right, so to solve for my hypotenuse, which is not the overall hypotenuse, I'm actually just looking at this medium-sized triangle. So adjacent is going to be the 18. Hypotenuse is going to be this bottom segment here. To solve for this, I'm going to multiply by hypotenuse. So I'll just do like that. So I multiply by hypotenuse. Those are going to cancel. And then I'm going to divide by cosine. So my hypotenuse is going to equal 18 divided by cosine of 33. And I'll actually punch this into a calculator and get a number. All right, so check your mode. Make sure you're in degree mode. So go down there, press enter. All right, so I'm going to do 18 divided by cos of 33. You get 21.46. All right, so this segment here is 21.46. Now, if I knew this piece, I could go ahead and use the Pythagorean theorem, but I don't have it. So I know I got two options here. I'm going to go ahead and use my 33 again, but this time I'm going to do opposite and adjacent. All right, that's going to be tangent. So remember, tangent is the TOA. So I'm going to say tangent of 33 is equal to opposite right here over adjacent, which is 18 again. All right. To solve for my opposite here, all right, just in this medium triangle, so just this segment right here, multiply through by 18, and you're going to get 18 tan 33. That's equal to the opposite. All right, as a actual number, 18 times tan of 33, 11.69. Yeah, we'll call it 11.69. All right, so this segment here is 11.69. All right, now I'm going to have to switch triangles. I'm going to have to look at my smallest triangle and use something there. So I only know one side right now of my smallest triangle. I'm going to use, I think I'm going to use this 57. I haven't used this 57 yet. All right, so this is a leg. All right, this is actually the opposite side of 57. This is a leg. So my hypotenuse is this longest side here. I'm going to go ahead and use sine 57, which is opposite. So it's going to be opposite over hypotenuse. Hypotenuse is here. And my opposite is this 11.69. Okay. All right, so to solve for the hypotenuse, you're going to multiply by the hypotenuse, so put that over here, and then you're going to divide by the sine. All right, I guess I'll do the steps here. Right, so multiply by the hypotenuse, and then you're going to divide by the sine. So that's going to give you 11.69 divided by sine of 57. There we go. 11.69 divided by sine of 57. 13.94. And that was this side right here. 13.94. Okay. The last piece is going to be this segment, or I could solve for the overall segment. Just depends on which piece you really want. Let's use 57 again. And the adjacent side to 57 is on this smaller triangle. The adjacent side is this AD. Yep. So I'm going to use cosine of 57, and that's going to be adjacent over the hypotenuse, and the hypotenuse is this longer side. So when you're looking at that small triangle, it's the longer side. Alrighty, multiply through by this 14 right here, and you're going to get cosine of 57 times 13.94, right, is equal to the adjacent side. All right, cos of 57 times 13.94. You get 7.59. All right, so this piece right here is 7.59. And that does it. We have solved for every single piece of this triangle. The whole length AC, that would just be, that plus this. Okay.